Hello, it's Keith here, and this is lesson 13 of the platform-specific series of my 6502 assembly tutorials. This week we're going to be looking at the Atari Lynx. Now, the Atari Lynx has quite an impressive joystick. It's generally a very impressive system, to be honest, as 6502s go, but we've got an awful lot of buttons on this system, actually more than we're going to use. So we're going to have a look at how to read it. And unlike the Apple II, which gave us quite a hard time reading in its input last week, this week is going to be very easy because it's a true digital joystick and it's going to give us pretty much what we want. We just need to move a few of the keys around. So first, let's have a look at the Atari Lynx and how it's physically laid out, because if it's not a system you're that familiar with, it may surprise you a little bit. So of course we have an up, down, left, right joystick here, which is pretty standard. We've got a B and an A button, which is very much like a system like the Nintendo NES. Now we also have two option buttons here, and we have a pause button here. And there are combinations that if you press option 2 and pause, you will flip the device so that you can use it as a left-handed device. And if you press pause and option 1, it will reset the game. Now, these are software functions. It's not built into the hardware in any way. But as you can see, we do have a second pair of buttons here, or here alternatively. Now, these are the exact same buttons as our A and B. You can't use them as a C or D or anything because they're wired to the same ports. But it does mean that the game could be used as a left-handed game or even as a vertical game in some real exceptions. But as I say, these buttons are limited. They are just two buttons, even though there's a duplicate one of them. Now, in these tutorials, we're going to be using A and B as fire buttons. We're going to be using option 1 and option 2 as an extra fire button and as a start button, but we're not going to be using the pause button in this case. Now, obviously, I'm breaching the sort of specifications there. We're not going to be worrying about flipping our game, but we're not going to be worrying about commercially releasing our game either. So I think we can be forgiven for that. Now, in these tutorials, we're using a common format. We're using a single byte, and we're using an up, down, left and right bits in bits 0 to 3, up to 3 fires in bits 4 to 6, and a start button in bit 7. Now we're only using a single byte per joystick, and that's why we're going to be ignoring the pause button in this case. Now if you wanted to use the pause button in your code, of course, you could just modify my example. It'd be fairly straightforward. But as I say, we're really looking for common code so that we can program for multiple systems as quickly as possible. Now, when it comes to reading in from the joysticks, it's very straightforward. All we need to do is read in from two ports. FCB0 is the joystick, the up, down, left, right, option 1, option 2, and the A and B fire buttons, inner and outer, as they're sometimes called. And inner refers to the button closest to the screen, and outer is the one on the outside of the case. As well as that, the pause is read in from a different port, FCB1, which also has two things called cart strobes, which aren't something we're going to need to worry about today. Now, when we read in from these ports, if a bit is 1, then the button is down. If it is 0, then the button is up. However, that's the opposite of the way these tutorials work. When we do our tutorials, if a button is down, then that is a 0 bit, and if it is up, then that's a 1 bit. So we're going to have to convert the bits, and we're also going to have to move them around because the order is the wrong way around for what we want. We want up, down, left and right to be here, and we want our inner and outer fires here with option 2, and then option 1 is going to be start for us here. So let's see our tutorial in action. So we're using this player read controls dual command here, which writes to two 0-page entries marked as ZH and ZL. And what we can do here, if I can just find my joypad, and so if I press up here, you can see this bit 0 changes. There's down, left, right, fire 1, fire 2, I think that is, fire 3, and there is our option button there. So you can see there we're reading from 4 joystick buttons and 4 directions. Now on the Atari Lynx we only have one controller. Now the second controller is totally unused here, so this is always going to be FF, and that's just to maintain consistency across our systems because we want to write code that can work on all systems. And so by setting the unused joystick to FF, we don't mean that there's no risk that the game is going to start because it thinks fire 2 is pressed down or something strange like that. So that's why we're setting that second port to FF there. Now, when it comes to actually reading in, it's very straightforward. What we're going to do first is we're going to set both joysticks to FF so that they are initialized and that any unused bits are not set. And then what we're going to do is we're going to read in all of the basic input from FCB0, which is our main buttons, as I said before. So up, down, left, right, option 1, option 2, and inner and outer fire. But first what we want to do is we want to swap these two nibbles around. And we're going to do this with a bit of a trick. We're going to call this function called swap nibbles. What this does is it moves the top nibble 4 bits and swaps it with the bottom nibble 4 bits. Now on a Z80 based system, we would just do a rotation command which rotates around within the byte. But unfortunately, of course, the 6502 only has rotation commands that rotate with the carry, which isn't really very convenient for us. So we're doing a bit of a trick here. We've got a command here. We've got a set of commands here which will shift 2 bits from the top to the bottom. And while it does use the carry, at the end of this command, the carry will be included as if we'd just done 2 rotates. So let's have a look at how it works. Well, the first thing it does is it does an arithmetic shift left. This puts the top bit of the byte into the carry and sets the bottom bit to 0. Now what we do is we add with carry hexadecimal 80. This effectively puts that bottom bit back in to the current byte, and because we're adding 128, we're effectively popping the top bit off again. Next we do a rotate left. This pushes that top bit out again and brings back in the bit that was just pushed out by the last command. So effectively what we've done is we've moved 2 bits to the left, but both of those 2 bits that were popped out have been pushed back in. And this uses 3 commands, and to my knowledge this is the fastest way on the 6502 of shifting by 2 bits. Now we do that twice and we've effectively shifted by 4 bits, swapping the 2 nibbles. So that's what we're doing here. So the first thing we're doing here is we are swapping the 2 nibbles around, and then what we're doing is we're backing up the value into the Y register here. Next we're going to need to swap the 4 bits around. Now we've just swapped these bits to here, but we've got up, down, left and right here, and we need these to be the opposite way around. So what we're doing is we are rotating right the accumulator, which contains the up, down, left and right, and then we're rotating them left into the player 1 value here, and that is effectively flipping the bits around here. So that's what we're doing there. And what we're doing next is we're getting the value back in Y here that we backed up, and this contains the up, down, left, right and the 4 fires, but this time we only want the 4 fires. So we're ORing to set the bottom 4 bits that we've already processed to 1. We're then adding in the value that we've just completed doing the up, down, left and right for, which is the player 1 value. This effectively sets the top 4 bits if they are 0, but doesn't affect the bottom 4 bits at all. We then store the resulting value in ZH, and this completes setting the player 1's up, down, left, right, 3 fires and an effective start button. And that's all we need to do on this system to get the joystick processed. So there we go. Now it is important to note, as I said, that the Atari Lynx was designed for left-handed play so that you could flip the screen around. Now this is a software function. There's no hardware function within the joystick to reverse the up, down, left and right. This is something you would actually have to do in your code. So it's not something we're going to cover in these tutorials. You would just need to reprogram, maybe with self-modifying code or something, your joystick button reading routines to allow them to be flipped. And of course with the sprites and the graphics as well. In some cases the graphics are able to flip themselves. The sprites, for example, can be rotated. But as I say, it's basically a software function, so it's outside of the scope of these tutorials. I'm always intending with these tutorials that we're programming for fun, not for creating commercial grade games. So in some cases we're ignoring the strict stuff just to get something that works fairly quickly. Anyway, that's all we're going to be covering today. I hope you found this interesting, and I hope you'll have a go with the Atari Lynx. Thanks for watching today, and goodbye.